Every breach you have ever heard about broke one of three things. Just three. A hospital gets locked out of its own patient records overnight. A bank leaks 100 million customers to the open internet. A trusted software update quietly turns into a backdoor. Different headlines, different companies, different years, but underneath, it is the same three targets every single time. Because all of security, every password rule, every firewall, every intimidating acronym on a certification exam, exists to protect exactly three things. That is it. Learn these three goals and the entire field stops looking like a pile of random rules and starts looking like a simple map. You will read a news story about a hack and know, in one sentence, what actually failed. On screen you will see these three labeled with just their initials, and no, despite how that looks, it has nothing to do with any spy agency. Ignore the letters for now, hold on to the goals. Security can feel like 1,000 disconnected rules. Use a strong password. Turn on two-factor. Encrypt the database. Patch the server. Rotate your keys. Back everything up. Do not click that link. It is a fire hose, and most people cope by memorizing a checklist and quietly hoping. But a checklist never tells you why any of it matters or what you are actually protecting or what happens if you skip a line. So the first time something strange happens, a weird login, a file that changed on its own, a site that will not load, you are guessing. You have got tactics with no strategy. What you are missing is the thing underneath the checklist, the small set of goals that every one of those rules is quietly serving. Get that, and the rules stop being chores to memorize. They become obvious moves toward a target you can finally see. But underneath all of it sit three goals, and every control you will ever configure serves at least one of them. The first goal, keep data secret, only the right people can see it. The second, keep data true, nobody can change it behind your back. The third, keep data reachable, it is there the moment you need it. Confidentiality, integrity, availability. Picture a triangle with one goal sitting on each corner. That triangle is the whole model. Every attack in history is really just an attempt to knock down one of these corners. Every defense you build is you bracing one of them. A password protects the first corner. A backup protects the third. Once you can see the triangle, security stops being a mystery and becomes a game of one question. Which corner is under threat and how do I hold it? Start with the first goal, keeping secrets. Confidentiality means only authorized people can read the data. Your medical history, your private messages, a company's source code, a list of credit card numbers, all of it should be visible to the right eyes and absolutely nobody else. How do you enforce that? Two big tools do most of the work. Encryption scrambles the data so thoroughly that even if an attacker steals the whole file, it is useless noise without the key. And access control decides who is even allowed to ask in the first place. Logins, permissions, roles, the simple idea that a junior employee just cannot open the payroll file. Think of it as a locked room with a guest list. Encryption is the lock. Access control is the list at the door. When this corner breaks, you get the headline everyone dreads, a data breach. Secrets end up somewhere they were never meant to be, and you cannot unleak them. The second goal is trust in the data itself. Integrity means the information has not been altered by anyone unauthorized. What you read is exactly what was written, down to the last character. Think about a bank balance, a signed contract, or the code inside a software update. If an attacker can quietly flip one number or swap one file, the data still looks perfectly normal while it lies straight to your face. That is often scarier than a leak, because you may never even notice. Defenders protect this corner with hashing. You run the data through a formula that spits out a short fingerprint, and if even one bit changes, that fingerprint changes completely. They use digital signatures to prove who really sent something, and checksums to catch accidental corruption. On screen you can watch it work. Hash the original, hash the copy, and if the two fingerprints do not match, someone touched it. Break this corner and you get tampering, numbers that do not add up and files that are not what they claim to be. The third goal is simple to feel and shockingly easy to forget. The system has to actually work when you need it. Availability means the data and the service are reachable. The website loads, the app responds, the records open on the first try. Perfect secrecy and perfect integrity are worth nothing if the whole thing is down when a customer, a nurse, or a pilot needs it. Defenders protect this corner with redundancy, spare servers standing by to take over the instant one dies. With backups you can actually restore from. And with defenses against flooding attacks, where an attacker drowns your servers in fake traffic until real users simply cannot get through the door. Availability is the corner that turns a security problem into a physical, real-world problem. No gas, no ambulance dispatch, no paycheck. Break it and the lights go out. A plain outage or worse, ransomware that locks you out of your own files and demands money for the key. Every corner has an enemy and a guard, and lining them up makes the whole field snap into focus. The secrecy corner's enemy is the eavesdropper and the thief. Its guard is encryption and access control. The integrity corner's enemy is the tamperer and the forger. Its guard is hashing and signatures. The availability corner's enemy is the flood and the ransom. Its guard is redundancy and backups. Notice the pattern. For each goal there is a specific way it fails and a specific defense that answers it, like a lock built for exactly one kind of key. So whenever you meet a new tool or read about a new attack, your very first question is just this: which corner? Is this thing trying to see what it should not, change what it should not, or take down what it should not? That single question sorts almost everything you will ever run into in security. Let me make this real with 3 famous disasters, one for each corner. Start with confidentiality. In 2017, the credit bureau Equifax was breached, and the personal records of about 147 million people spilled out: names, birth dates, addresses, and social security numbers. 147 million. That is not a rounding error. That is roughly half of the United States. And notice what did not happen. No files were deleted, nothing went offline, no numbers were secretly changed. The systems kept running just fine. The only thing that failed was secrecy. Data that was supposed to be visible to that company and nobody else was suddenly in criminal hands, permanently. That is the confidentiality corner shattering, and it is why we got breached almost always means this exact corner. Now flip to the second corner, integrity. In 2020, attackers slipped malicious code into a routine software update from a company called SolarWinds. Here is the truly unsettling part. The poisoned update was digitally signed and looked completely legitimate. Around 18,000 organizations downloaded and installed it, trusting it, because every signal told them it was genuine. It was not. The data, the update itself, had been tampered with at the source before it ever reached anyone. That is an integrity failure in its purest form. Not a stolen secret and not an outage, but corrupted information that thousands of smart people trusted was clean. It shows exactly why we obsess over fingerprints and signatures. When you can no longer trust that the file you installed is the file the vendor actually built, the entire chain of trust quietly collapses. The third story is the scariest because you could practically see it from space. In 2021, ransomware hit Colonial Pipeline, which carries close to half of the fuel for the entire United States East Coast. The attackers did not leak secrets or forge data. They encrypted the company's own systems and demanded a payment to unlock them. The pipeline shut down for days. Gas stations ran dry, prices jumped, and people lined up in a panic. That is the availability corner going down. The data and the systems were still there, technically intact but completely out of reach. Ransomware is the defining modern nightmare precisely because it attacks availability head-on. It takes something that is yours and makes it unusable until you pay for the privilege of getting it back. Here is the pro move that makes you sound like you actually get security. For any incident, just ask which corner broke. Passwords dumped online. Confidentiality. A booby-trapped app update. Integrity. A website knocked offline by a wave of junk traffic. Availability. Ransomware is the interesting one. It is mainly an availability attack, but modern gangs often steal the data first and threaten to publish it, which means it hits confidentiality too. So yes, one event can break more than one corner at once. But naming the corners is powerful because it tells you precisely what went wrong and which defense should have caught it. You stop reading these stories as scary, formless chaos and start reading them as a labeled diagram. Which corner and what was supposed to hold it. But here is what nobody tells you when they draw the triangle. The 3 goals actively fight each other. Crank secrecy to the maximum, bury everything under layers of encryption and approvals, and you can quietly wreck availability. Because now legitimate people wait, get denied, or get locked out at the worst possible moment. Make something instantly available to everyone with zero friction, and you have probably just weakened confidentiality. Pile on so many integrity checks that every action has to be verified twice, and availability suffers again as the system crawls. Real security is not about maxing all 3 corners. That is impossible. It is about deciding for this specific data which corner matters most and consciously accepting the trade-off. A public blog leans hard on availability and barely cares about secrecy. A hospital's records lean hard on confidentiality and integrity. There is no universal right answer, only the right balance for the thing you are actually protecting. So how do you actually defend all 3 in the real world? Map each corner to its own toolbox. For secrecy, encrypt data both when it is stored and when it is moving across the network and give every person the least access they need to do their job, nothing more. For integrity, hash and sign your data and your releases and log every change so tampering always leaves a footprint. For availability, keep backups you have actually tested by restoring them, run redundant systems, and put protection in front of anything exposed to the internet. If you want the industry's security's own cheat sheet, the group behind the famous top 10 web risk list has spent years cataloging exactly how these corners get broken in real applications. And one habit ties it all together. Assume something will eventually fail and design so that when it does, the other two corners still hold the line. A few things that will quietly trip you up. First, your security is only as strong as your weakest corner. Flawless encryption means nothing if the system is trivially easy to knock offline. Attackers always go for the soft corner, never the hard one. Second, availability is the corner people forget. Teams obsess over secrecy, set up beautiful encryption, and then never once test whether their backup actually restores. So a bad day turns into a full catastrophe when the restore silently fails. Third, these goals apply to far more than a database. Your login system, your servers, your third-party dependencies, even your team's laptops, each one has all three corners too. And fourth, a serious defense never pretends to perfect all three. It knows which corner leads for this particular data, and it protects the other two just enough that no single failure is allowed to end the whole story. So let us tie this together in 3 lines. 1. All of security exists to protect 3 goals: keep data secret, keep it true, and keep it reachable. 2. Every attack breaks one of those corners and every defense braces one, so your first question is always simply which corner? 3. You cannot maximize all 3 at once, so you balance them for whatever it is you are protecting. That triangle is the quiet map sitting under every headline, every tool, and every intimidating acronym you will ever meet in this field. Memorize the corners, and everything else finally has a place to hang. If this finally made security click, you are going to love where this series goes next. We are building straight up from here into how logging in actually works. The tokens, the sessions, and the invisible handshakes behind every single sign-in button you have ever tapped. It is the Confidentiality Corner in action, up close. Subscribe so you do not miss it, and drop a comment with which corner you think gets ignored most. Next in the series, how logging in really works. Learn these 3 corners, and the rest of security is just the details.